before we look at a formal definition of partial df dx, partial df dy, let's go back and just do a recap on what dy dx is. And dy dx was the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So that was a formal definition of dy dx, and the definitions of partial derivatives are very much linked into these as well. So partial df, so if you've got f of x, y, and that's equal to z, z's a function of two of those variables, x and y, so partial df dx equals the limit as delta x approaches 0. Let's just make that delta x a little bit clearer there. Partial is the limit as delta x approaches 0 of f. Now don't forget, f is a function of both x and y, so that'll be x, only x changes, so don't forget y stays constant, so that'll be x plus delta x y minus f of x y all over delta x. So that's the formal definition of what partial df dx is, and partial df dy is the limit as delta y approaches 0 of f. Now, if we're doing with respect to y, partial with respect to y, x stays constant. So this will be x comma y plus delta y minus f of xy all over delta y. Okay, so that's just the formal definition. It's linked very much to what you've already been taught and you know from previous work, introduction to calculus. So this is the formal definition of partial df dx, partial df dy.